Well, hi everybody. My name is Peter Herman. I'm a research methodologist at NORC at the University of Chicago. I'm presenting with my colleague, data scientist Karina Hoyer. We're coming from this organization, NORC, which is one of the largest social science research organizations in the United States. We run the General Social Survey. We do the political polling for the Associated Press, among many other projects. Since we work a lot with statisticians and social scientists or public health people, we're really heavy R users at our company, and so we're going to be using that for some of our code examples, but everything that we present here can be done in Python as well. We're also speaking at the end of this conference, and Carina and I have been joking about this. We're pretty sure that you guys might know a little bit more about web scraping than even we do, based on some of the presentations that we've seen. So keep in mind this presentation is for beginners. So you've been warned, okay? We're going to talk to you about how to scrape data from web maps. We're going to show a couple different methods. Broadly speaking, there are 3 of them. Scraping data from HTML and XML using queries, copying data from the fetch requests in the Elements tab of Google Chrome, and finding and using undocumented APIs where maps are pulling data from. If you're not familiar with web scraping, what we're essentially trying to do is take data that's presented in a web map and then use that data to build a tabular data set. For example, you can see I have a set of coordinates in a leaflet map here that shows vape stores in Chicago. We're trying to take that data from that web map and then scrape it from the website and create a table that looks like the one below that has our coordinates and then also the associated data in the HTML elements that correspond to those markers. So in this case, it's the vape store name. Scraping data from web maps is a little more difficult than typical web scraping, right? Web maps are dynamic. They consist of HTML or SVG that populates and doesn't really exist in the web page until it is opened up by a user, right? So it means that a typical HTTP request like the one at the bottom of this slide, which is written in R using the rvest package, which I'll show a little bit more of later, when you pull the URL that has that vape map I just showed you on it, using this, you will get the map, you will like pull the entire website, and the div where the map data lives will be empty, right? Because that information isn't rendered unless a user actually goes up and has the browser open. You'll also see that, you know, when only for the most part, in a lot of web maps, especially leaflet web maps, the data is not really saved when you change the map view, right? So if you're scrolling on that web map I just saw you to the south side of Chicago instead of the north side, all the north side points suddenly don't render anymore, and then you have to go back and find that data using another method. So web scraping really works well on maps that are showing vector data, so points, lines, and polygons. If data is rendering an image, it's a lot more difficult to scrape, okay? Some web maps also load all of their data on the front end. For these kinds of maps, it's going to take a lot more effort to find the data than it is when you can just use the Elements tab of Google Chrome tools, which we'll show you in a couple minutes. This isn't really that common because, of course, it increased load time a lot, but if you can't find your data being loaded into the tool via HTML or in the Elements tab, you got to start using Control-F in web developer tools to find, you know, a GeoJSON or TopoJSON string, because all that data is being loaded in the front end. And then finally, there are some maps that load data from sources that require authentication, like some ArcGIS online servers. It's going to be very difficult, if not impossible, to scrape data from those. So let's just go through kind of the basic toolkit, and we'll show you guys a lot more about these as we go through our sort of examples here. But a basic web mapping toolkit consists of the developer console in your browser first and foremost, and then either a GUI-based Python or R-based method or for cleaning the scraped data, then make it into the format you want. Again, and in this presentation, we're going to show how to do this in R, and then also how to do it using Google Sheets for a sort of kind of no-code option. So let's get into it. Let's see a little bit of web scraping 101 using R, HTML. So NRC did a study with the Truth Foundation, so the anti-tobacco smoking group that you've seen like many Super Bowl ads for, about the effects of the proximity of tobacco points of sale on youth smoking rates. And a lot of the point of sale data we got was scraped from websites like this one, Vaporsmap. Okay? Web scraping is pretty easy to do with commercial data that business owners like want to be found on the web. So to start scraping this web map, what we did was right-click and then click the Inspect button to open up Google Chrome Developer Tools. When you open Inspect, you'll be guided to the part of the site HTML where you right-clicked on, right? So we right-clicked on the map, then you'll see this is the map div that has opened up for us. In our case, we want all of the data associated with these different map points, right? We want to see where these stores are and what they're named of. So the easiest way for us to do this is to copy the store name, which we know renders on the map through this pop-up, which we can get by clicking on these different points, and then using Control F in the Elements tab of Google Chrome Developer Tools, which is where all of the HTML for the site lives, and then find exactly what the name of, using kind of vape store name, we can find exactly where the point data is within the HTML. So in the Elements tab using Control F, we found this, the associated point that corresponds to the tobacco store. And the reason that we know that this is the correct element that we have found is that as you kind of scroll over your different elements on the Elements tab of the Developer Tools, what that element corresponds to in the site will be highlighted in the blue box. So since we'll see our point is highlighted, we know that that corresponds to this div element here. So what I did is I copied this div, and then I copied another div right below it that corresponds to a different vape store, and I pasted that into a sort of easier to read text editor, this one being Sublime Text. And what I'm trying to do here is think of what is a query that I could use, like a CSS query, that could capture all of the different points in my HTML, right? So if I want to find things that look like this, because this has the data I want in it, you'll see there's a title element in the divs, or a title argument in the divs, that is the names of the different vape stores. Unfortunately, it's kind of difficult to create a CSS query that would target both of these, right? There is no shared HTML class name between them. In fact, there's very, very little that both of these elements have in common, of course, except for their structure, right? These are both div tags that contain image tags as their sort of children elements. This is enough to create a query that will get the data for us. And also, this is going to be true for every leaflet map that you see online that contains points that are markers that look like the markers we just saw, right? Because each of those markers is going to be an image that is within the parent div. So as I mentioned at the top of the presentation, web maps are dynamically generated. So the HTML associated with these points I want to scrape won't be created unless a user actually opens the web page. So what I'm doing here, again, because this is an introductory presentation, is copying all of this giant, all of the map HTML here, just using copy paste from Developer Tools, and I'm pasting it in a separate file that I'm saving as vaporsmap_leaflet.html. So this is a local HTML file that I have created by copying, pasting from Google Chrome Developer Tools that I am then reading in R using the rvest package. So let me go through the different lines of code in my R script on the right-hand side here. First, you assign the local URL, and then you use read HTML to generate in R, in the rvest package, what is a giant list of all the different HTML elements. I can then use the HTML_nodes function to subset this to just the divs. That's not very helpful, of course, div being the most common HTML element. But then I can keep only the HTML nodes that have an image as their child using the keep function from the perf package. If there is no image tag, or if the image tag doesn't contain any image data, is null, then I do not keep those. So I only want divs that have children who are images. And then once I have my list of divs who are images, I can use the HTML_attribute, ATTR, to grab the title of these and then generate my list of vape stores in Chicago. Unfortunately, there was no place in this HTML where we had coordinates, right? So I don't have the coordinate data. I just have the HTML attribute data. We'll talk about how to get the coordinate data when Carina starts her other half of the presentation. So you don't really need to be a programmer to scrape data like this. Google Sheets can scrape HTML using the import HTML function, but the only HTML elements it can scrape are ones that are stored as either tables or lists, and that is pretty rare for mappable data, right? Google Sheets, on the other hand, is very good at scraping XML data because one can do the same type of filtering that you just saw us do in R using the rvest package using Google Sheets. So we often have to use web scraping with our international clients when we're trying to find international data. One of our international clients is the USAID mission in Mongolia, and here is a list of the building, is a Mongolian census website with building footprints in Ulaanbaatar, Mongolia. Using a method that Carina is going to show you a little later in the presentation by accessing the Google Chrome Developer Tools Elements tab, or excuse me, Network tab, we can find the XML data that is behind this Mongolian Census Bureau site, and carefully reading this, we can, you know, this XML file that you're seeing here exists at its own URL. You can read at the top of the page, and then copy into Google Chrome and submit a query that will get the actual coordinates that you want so that you can create the shape files that we just saw on the census site. And the way we do that is by first locating the XML portions that contain geographic data. So we're basically looking for our coordinates in the giant XML file. We can see there's a lot of coordinate data for the different building footprint boxes, right? Those kind of square boxes that correspond to the different rectangles that are buildings in Ulaanbaatar. They're all in this XML element called WGS84 bounding box. And so when we do our query, which is the XPath query argument on the bottom part of the screen, this bottom part of the screen contains the code that we enter into the cell in Google Sheets. This is like a really simple Google Sheets function. You will see that the top part of that import XML function is the URL from the Mongolian Census Bureau website that we found in the Google Chrome Network tab. And then we run this XPath query to only return things that look like our coordinates here, right? So we can see our XPath query is looking for a local name, WGS84 bounding box, and then contains the elements lower corner and upper corner, which are the elements that contain our coordinates. When we run this in Google Sheets, we will get a list of the coordinates we want from XML. And that is going to be, and we can use that then, right, to build our own bounding boxes using GeoJSON or TopoJSON or any other type of kind of mapping software. And with that, I'm going to turn it over to Carina.
Hi, I'm just going to show a couple more options for web scraping. The Elements tab is, let's see, sorry. I just had another cup of coffee, so. Most of the time, web scraping geospatial data requires a little bit of poking around. The two options that Peter showed kind of were a little conclusive, but the next two, you'll probably have to use that Control F a couple times or just kind of be interested in the back of the website. This instance, we actually just kind of got lucky when we were looking on this site for LGBT population. We accessed the Elements tab in Google Chrome, and we actually found the data just like in a formatted CSV, and it was awesome. Again, you're going to right-click, and you're going to go to Inspect. The Elements tab is going to be right in that same spot that the Networks tab is, and you're going to go within that to this Fetch XHR tab. You'll probably notice that at first, that Fetch XHR tab has nothing populated in it. You'll have to refresh the screen or reload a filter or something to get that map to reload, and then all of the data in the background will pop back up in there. So you can see that now in that screen. So this is the instance where we just got lucky. After some poking around, you can see on the left side there, all of our data is in there. We found the exact CSV that we were looking for, and from there we literally just copied and pasted the text into R. We use R, but you can do it into Python or whatever else you're using. Alternatively, you can also call undocumented APIs. I will show that example by using the Greater Chicago Food Depository website. After identifying the area that was of interest for me, which was downtown Chicago, I wanted to get that exact buffered data. Again, I went to that same exact spot, the FXHR tab in Google Chrome. I reloaded the page. This one I reloaded the full page. And this one was a little bit different because instead of the data showing up, we had the data in a bunch of different APIs and a lot of different stuff coming up. So I definitely required quite a bit more searching. After I found the identified API, which frankly it took me 3 times, I did 2 APIs and it was just for 1 point. And then I finally found the one that was the whole background of the data that was being sourced there. You actually right-click and you copy as curl. It's important to note that you want to copy as curl bash and not the command. And we actually then go into a third-party website to help convert that curl into our code in our instance, but this website is really great and there's a ton of different options that you can convert the curl code into. So I go into my curlconverter.com is what it's called. And there's also a GitHub repository, but I just go to the website because it's easy. I copy the code directly into the box, and in my output language, I put R. If you are an R user, there are now 2 options where they have the HTTR library. There's a new update, but for some reason, it copied it kind of weird, so I just used the base HTTR, not HTTR2. And just copy it right in your clipboard. And then I go into RStudio, whatever language everyone else uses, it's probably pretty replicable. I add my new script, and then you are gonna need JSON library for this. I paste my curl converted code. And first, I have to extract the actual content from the API. So to do that, you just run the full curl converted code. It's really quite frighteningly simple. And you can see it directly in like the data section of your RStudio as content. And you can kind of look over and make sure that your content was being extracted. And then from there, this is where I pull in my JSON library, and I just do a couple pretty quick, I do a quick function and a couple typical kind of data analysis tasks to get a nice clean data frame from the response. Here, I did a quick screenshot, so I didn't actually capture the geospatial data, but it is in there. I also have the actual, like, the counts of, like, the flags and all of the full data set from the website. We also wanted to touch on a few best practices for web scraping because it can be a slippery slope, and it's important to not be a jerk on the web. So we wanted to start with always read the terms and services. Of course, we all know that they're kind of annoying, but it is important to be ethical. Default to using a public API if it's available, and often it is easier if you have to go into multiple ways of like looking through APIs. It can just be straightforward. Only save the data that you need as a best practice. Request data directly from a group if applicable. I actually came into this when I'm working on a gun violence study, and I got kicked off a website, the Gun Violence Archive, after downloading after doing 2 runs on an undocumented API. So I just emailed them and said like, hey, this is what I'm using the data for, and they sent me all the data. So it actually ended up being nice. Always cite your scraped content and respect the robots text, which in RStudio, there's this new package called the Polite package, and it promotes responsible web etiquette. There's 2 main functions. One is really the only one that we would use with geospatial data, which is bow, which just directly asks for permission with the robots text file. And then scrape, which if you're doing something that's not with geospatial data, then you can use the scrape option, and that just, as it says, scrapes the data. And then finally, there's really good documentation that's updated pretty consistently with the Automated Internet Data Collection Review Board. That is pretty much what the census works with them, and so they put out like a yearly documentation about like, please do this, please don't do this, and it's pretty concise, and I think like 5 pages or something. So keep up to date with that and always read that. And with that, thank you. Oh, right, also questions, please.